Hi everyone. Today we will start the third chapter of polynomials, and here in this chapter we are going to learn about the divisions which we are doing in polynomials. But to my knowledge you had been doing divisions in 9th standard, and let us continue. We are just going to understand what is the relationship between a divisor, dividend, quotient and a remainder. And to tell it in a simple form, we can write it as, usually we represent polynomial as p of x. So p of x is going to be the dividend. We are going to divide p of x, okay? And when we divide p of x with a g of x, we get a divisor d of x along with a remainder r of x. This is the only logic which we are going to use in the whole of the exercise. And now we will go to the first sum. Divide the polynomial p of x. Okay. And I am going to do the normal polynomial division. Square plus 5x minus 3 divided by x square minus 2. Here the only part what you have to take care is, always take care to write the values as per its degree. The degree should be always in the descending order. And suppose if one of the degree is missing, suppose your x square here is there, but suppose if x square is not given, then leave a space or a gap. You can write a 0 also. If you are very comfortable, you can write a 0 also. Leave a gap and then write the next term. The same applies to here also. Okay. So whenever you are writing, also you have to write below. While you are writing below also, you have to take care to write along with the degrees value. Okay. Now going back to the sum, x cube divided by x square. Always maintain a very perfect rough column. While you are doing polynomial division, always maintain a perfect rough column. Even though I am calling it as rough column, make it as far as possible. Any mistake you are doing here, only that is going to help you. So maintain it very perfectly. Take the first term here divided by the first term, not the other terms. Just the single first term alone. While along with the symbols of it. Take care about the symbol. X cube divided by x square and it values to x. Write it first, write it. Even though you know the answer, many people tend to forget to write this term. So write it first. Then multiply x into this. X square minus 2. Multiply it. X into x square is equal to x cube minus 2 into x minus 2x. Now write it. I said along with the power of the x. Okay. X cube. So I have written x cube. The second term is minus 2x, not x square term. So I am leaving a space here and I am writing it here minus 2x. Then it's going to be subtraction. So as it is subtraction, I am changing the symbol. Okay, so this term gets cancelled. Remaining this term plus 5x plus 2x. So it sums up to be plus 7x. Okay, bring this term now here. Minus 3x square plus 7x. Okay, and minus 3. Now take this first term, divide it again. Minus 3x square divided by x square. X square get cancelled. The answer is minus 3. Don't forget to write this term. Okay. Then minus 3 into x square minus 2. It multiplies to be minus 3x square minus into minus plus 2 3s are 6. Again write it carefully along with the degrees. Okay. Here we don't have an x term. Go below. Write it below here. And again I am going to subtract. So change the symbol and this sums up to be no term here. So here 7x and minus, again both are minus signs. So it adds up to get sums up together to be 3 and 6 sums up to 9. So 7x minus 9. So q of x is equal to x minus 3 and r of x is equal to 7x minus 9. Okay, I think you would have got it now. We will try all the sums. By the end of the exercise, you will be very sure of it, confident about it. The only thing is, take care about the symbols. With that, you will get all the sums very perfectly correct. Okay. The second sum, and g of x square plus 1 minus x. As I told, here one term is missing, x cube term is missing, and then here they have changed the places. Okay, so we have to take care about writing it. That's all. X power 4. If you want, you can specify it as plus 0, and then go with the next term 3x square plus 4x plus 5. And while writing here also, arrange it properly. X square minus x plus 1. Okay, the rough column here again, x power 4 divided by x square. X power 4 divided by x square, and it's equal to x square. Write it down, x square. Then x square into x square minus x plus 1. When I multiply it, I get x power 4 minus x cube plus x square. As I said again, take care it writing the terms properly. Okay, x power 4 minus x cube. We introduce the 0 to write the cube term only. Then plus x square. We are subtracting, so I am changing the symbols. So this term gets cancelled. This term comes down as plus x cube, and this term both are minus, so I add it up, 4x square, and bring the next term down. Okay, then I am dividing x cube by x square. X cube divided by x square, and that is equal to x power 1, or else I can write only as x plus x. Okay, x into x square minus x plus 1. This I have written, I am multiplying it now. X into x square, x cube minus x square plus x. Write it properly along with the degrees. Minus x square plus x. As it is subtraction, I am changing the symbols. So this term gets cancelled. The remaining minus 4 plus 1. So it becomes minus 3x square. And this term plus 4 minus 1. So minus 3. And I am bringing the next term. So minus 3x square divided by x square again. And this is equal to minus 3. Write the minus 3 here. Then again multiply. Minus 3 into x square minus x plus 1. Multiply, we get minus 3 into x square minus 3x square. Minus into minus plus x. Plus 3x again, 3 into x. So plus 3x. And minus into plus, it becomes minus 1 into 3 is 3. Minus 4x square, and this term gets cancelled. Minus 4x square plus x square minus 3x square plus 4x minus x is plus 3x plus 5. And it comes to be minus 3x square minus into minus, it is plus 3x minus 3. And when again I subtract, so I am changing the symbols. So this term gets cancelled. This term, even this term gets cancelled. Only this term, constant term alone is there. Plus 5 plus 3, it sums up to plus 8. So the, see, I left out this term again. So this sum, quotient of x is equal to x square plus x minus 3. Remainder of x is equal to plus 8. That's it. And we'll go to the next sum. We'll write it as x power 4, x cube term is missing, x square term is missing. So I can add it 2 numbers, or I can leave 2 spaces. Okay, minus 5x plus 6. As in the earlier sum I wrote 0. For this sum I am just leaving space. Okay, here minus x square plus 2. Again I am arranging it as per the descending order of the degrees. Okay, now rough column, x power 4 divided by x square. Take care about the symbol minus x square. So the answer is minus x square again. minus x square. Minus x square into minus x square plus 2. When I multiply, minus into minus plus x power 4. Okay. And then minus into plus minus 2x square. So I am writing it here as x power 4 minus 2x square. I subtract, so I am changing the symbols. This term gets cancelled, only this term comes down. 2x square minus 5x, then again 2x square divided by minus x square. This first term, so minus x square. The answer is minus 2. X square and x square get cancelled. Minus 2. Then minus 2 into minus x square plus 2, and this multiplies to be minus into minus plus 2x square minus into plus again minus 2 2s are 4. So 2x square minus 4 plus 6. I am bringing that term also down. So this comes up to be, again I have to change the symbol because it's a subtraction. So this term gets cancelled. 5x minus 5x plus 10. So q of x is equal to minus x square minus 2. Remainder of x is equal to minus 5x plus 10. And why I am stopping here? The degree here of x is 1, but the quotient is x square 2. But here I have only 1. So this is a smaller number than the divisor. So I am stopping with this. Okay. So this is the end of the sum. This is the end of the third sum. Then the second sum is, they are given again a p of x and a q g of x, and they are asking us to find whether g of x is a factor of p of x. So what's the meaning? The remainder should be 0. Only that is the meaning of the question. If the remainder is 0, then we can say, conclude that the divisor is a factor of the question. Okay, p of x. Then the second sum, the first sum and the second sum. The given number is, I write it directly as division. Okay, instead of writing it as p of x, I write it directly. 2t power 4 plus 3t cube minus 2t square minus 9t minus 12. It's divided with t square minus 3. Okay. Again, all the terms are as per the descending order, so no problem in it. And this also in descending order. Now I am taking the first term alone. 2t power 4 divided by t square, it's equal to 2t square. 2t square. And now 2t square into t square minus 3. It's equal to 2t power 4 minus 2 3s are 6t square. I will write it along with the place value. So 2t power 4 minus 6t square. I didn't write it here. Below the t square term I have to write. Again, change the symbol as it is subtraction. This term gets cancelled. Bring this term down. 3t square. This term plus the positive number is the bigger number. So I am writing it as plus 6 minus 2. So I get 4t square. Bring the, okay, we'll see. Bring the, so I am taking the first term here. Again, 3t square divided by t square. Sorry, 3t cube here. Okay. 3t cube divided by t square. So I get 3 and t alone plus 3t. Okay. 3t into t square minus 3, and that is equal to 3t cube minus 3 3s are 9, 9t. So I write it as 3t cube minus 9t. Again I am writing it below the terms properly. Okay, that is the most important thing in polynomial division. Then I am changing the symbols again. So this term get cancelled. This term I am writing it below 4t square, and this term also is getting cancelled. I'm bringing the next term down, minus 12. Okay. Then this term t square, this term is also t square. So we can continue with the division. 4t square divided by t square, and that is equal to 4. So here plus 4. And 4 into t square minus 3. It's equal to 4t square minus 3 4s are 12. So 4t square minus 12. And then I am changing the symbol again. So both the terms get cancelled. The remainder becomes 0. And so I can write yes, t square minus 3 is a factor of p of x. This is the p of x. I have divided it. I got a 0 as a reminder. So it means t square minus 3 is a factor of the p of x. Okay. The second sum and the second main. The divisor is going to be 3x power 4 plus 5x cube. Again x power 4 x cube plus 7x square plus 2x plus 2, and it's divided by x square plus 3x plus 1. Okay. And we are seeing whether everything is arranged as per the descending order. Yes, all the degrees are arranged as per descending order. So we are going to continue with the division. So first term 3x power 4 divided by x square, and that is equal to 3x square. 3x square, and I multiply, I get 3x power 4, and the next, sorry, I'll multiply it here, then I will copy it. X square plus 3x plus 1, 1. When I multiply 3x power 4, 3 3s are 9, so 9x plus 3x square. Okay, I'm writing down all the terms here. 3x power 4 plus 9x cube plus 3x square. We subtract. So the terms, I'm changing the symbols of the terms. If I have a plus here, I change it to minus. If I have a minus, I change it to plus. That's all. And this term gets cancelled. Here the remainder is 4x cube. And this both are minus sign. So negative numbers, I can sum up both the numbers. Minus 7, minus 3, it sums to be minus 10x square plus 2x. I am bringing the next number down. Then I will take the first term alone. Minus 4x cube divided by x square. It's equal to minus 4x. Write it down. Minus 4x. Then minus 4x into x square plus 3x plus 1. It's equal to minus 4x cube plus into minus again minus. So 3 4s are 12. X square minus 4x minus 4x cube minus 12x square minus 4x. I subtract, so I am changing the symbol. This term gets cancelled. Plus is a bigger number. Positive number is a bigger number. So 12 minus 10, 2x square. And this one again, the negative positive number, both are positive numbers. So I add it up. 4 plus 2, 6x. Okay. And bring the next number down. Plus 2. Now take this term alone. 2x square divided by this x square, and it is equal to 2 plus 2. Then I multiply again. 2 into x square plus 3x plus 1. It is equal to 2x square. 2 3s are 6x plus 2. And 2x square plus 6x plus 2. I am changing the symbol as its subtraction. So all the terms gets cancelled and it's becoming 0. It means this x square plus 3x plus 1 is a factor of P of x. That is the result what we wanted. Then we'll go to the third sum now. And students, please take care about the, while you're taking and writing in the rough column, take care about the symbols, plus and minus symbol. And if you're going to be little bit cautious, you will get the sum correct. These sums easily it will carry 3 to 4 marks. So please be careful with the symbols. Okay. And suppose if you are getting something wrong, just strike it off and start from the beginning fresh. Okay. Because it's very tedious to find a mistake, to locate the mistake. So strike it off and start from the beginning. Okay. X power 5. And there is no x power 4 term. So I am just giving a gap here. 4x cube plus x square plus 3x plus 1. Okay. X cube minus 3x plus 1. The third sum in the second main. And I will take the first term, x power 5 divided by x cube, and it's equal to x square. So I am writing it x square. Then I multiply x square into x cube minus 3x plus 1. When I multiply, I get x power 5 minus 3x cube plus x square. X power 5 minus 3x power 4 plus x square. Then even here there is a x square term missing, so there is a gap here. Okay. Then when I subtract, minus 1 x cube plus this term fully gets cancelled, so I bring that term down, plus 3x plus 1. Minus 1 x cube divided by x cube, it's equal to minus 1. So minus 1 here. Then minus 1 into x cube minus 3x plus 1, it's equal to minus x cube plus 3x minus 1. And I tend to change the symbol as it is subtraction. The first term gets cancelled, the second term also gets cancelled, the third term plus 2 I get. So it gives a remainder. Because of that, only one constant, even though only one constant is changed, as it is giving a remainder, this term x cube minus 3x plus 1 is not a factor of the given polynomial p of x. Okay. So you have got now division, polynomial division. And now we will go to the next sum. The given polynomial is 3x power 4. The third sum in this exercise. 3x power 4 plus 6x power 3 minus 2x square minus 10x minus 5. And they have given two zeros of this polynomial. So reminding you back, the zeros of the polynomial. What is the meaning of the zeros of the polynomial? I can understand that this value x power 4 has got 4 values. This x has got 4 values. When I am going to substitute those values, those zeros in this polynomial, the value of the polynomial becomes 0, and we call those numbers as the zeros of the polynomial. In this sum, they have given the two values of the polynomial are square root of 5 by 3 and minus 5 by 3. Square root of minus 5 by 3. These two numbers are the zeros of the given polynomial they are given. And they are asking us to find the other two zeros of the given polynomial. So, with these two zeros, first we have to make them as a factor. What does this mean? I can say that x is equal to square root of 5 by 3 and one more value of x is equal to minus 5 by 3. Can I bring it to the left hand side and write it as x minus square root of 5 by 3 and this term as x plus square root of 5 by 3? Yes. So these two are factors of this polynomial. If I multiply it, even then that's a factor of this polynomial, right? So I'm going to multiply these two terms. And what does this look like? I surely you'll be remembering this look like an identity, right? A plus b into a minus b, and that is equal to a square minus b square. Even if it is not looking like an identity, you are supposed to multiply. Okay. Usually they give some identity only. Here the identity is a plus b into a minus b, and that is equal to a square minus b square. One of the most important identity. Okay. Now, so this both the factors when I multiply, it becomes a square. This is a square term minus the b square term. 5 by 3 whole square. Okay. So when I square, the square root is gone. So it becomes x square minus 5 by 3. This is a factor of the given polynomial. By dividing this p of x with this factor, I can find the other polynomial. Again I have to factorize and I will find the other two factors of the polynomial. It's not a long sum which you can't understand. It's by little bit longer, but it's easy to understand. Okay. And this is the longest sum you will have in polynomial. So just don't leave this sum. It's very easy sum. Okay. So till this you will be understanding. I have converted the zeros into factors here, and I multiplied it and I got this number. I am going to divide this is p of x with this g of x. The same polynomial division. Okay. We will continue with the polynomial division. X power 4 plus 6x cube minus 2x square minus 10x minus 5. I am going to divide it with x square minus 5 by 3. You might get scared seeing a factor. Denominator. Don't get scared. Those numbers will get easily cancelled. Okay. We'll continue with the division. The rough column, usual rough column. 3x power 4 divided by x square. Normal division 3 and x square. So it's 3x square here. Then multiply 3x square into x square minus 5 by 3. As this is having a denominator, I am going to write it separately. That's all. I will multiply it now. 3 into x, 3x square. So 3x power 4. Then the next term, bracket it. 3x square into 5 by 3. I told, right, the 3 gets cancelled. So the remaining is minus 5x square. So 3x power 4 minus 5x square. Bring it down and write it as per its place value. 3x power 4 minus 5x square. Okay. Then I am going to subtract now. When subtraction, I have to change the symbol. This term gets cancelled. Bring this term down. 6x cube. This term, the positive number is a bigger number. So plus 3x square. Then I am continuing with the division now. 6x cube divided by x square. 6x I get. So plus 6x. Then 6x into x square minus 5 by 3. 6x into x square is 6x cube minus again 6x bracket like 6x into 5 by 3. This 3 and the 6 gets cancelled. I get 2x there now. 2x into 5. Okay. 6x cube. 2x into 5 is 10x minus 10x. So I am taking it and writing it here now. 6x cube, and here it's x square term. So write it separately here. Minus 10x. Bring that term also from the. And now I subtract it again. So I am changing the symbol. The first term it's getting cancelled. The remaining term is 3x square. This term it gets cancelled. So I am leaving it. I am bringing the next term down minus 5. here again I take this 3x square divided by x square and it's equal to 3. So plus 3 and again 3 into x square minus 5 by 3. It's equal to 3x square. 3 and 3 gets cancelled. So only minus 5 is left there. 3x square minus 5. As it is subtraction, I am changing the sign. So both the terms also get cancelled and we get only 3x square plus 6x plus 3. Okay. So what do you understand? First I got p of x. I made this as a factor and I divided. As this is a factor, I get a remainder 0. Okay. So it is a proved. It's a factor. We have proved. Then we have to find the two more zeros. Here we have x square. So when I factorize this polynomial, I can get two zeros of the other two zeros of this polynomial. Okay. Now I am going to factorize it. This 3 into 3 is 9. I want the product of the two numbers should be 9 and the sum of the two numbers should be 6. So obviously it will be 3 into 3. Okay. So 3x square plus 3x plus 3x plus 3 and that is again I take the common term outside. 3x is a common term, x plus 1 and here also I get 3 outside, so x plus 1. So x plus 1, 3x plus 3. 3x plus 3. So the zeros of the polynomial is, these are two zeros and we have got these when we multiplied and we made it as 1, right? We will make it as 2 again. So the zeros of p of x, okay? Because I can't write again the whole term. If you want, you can write p of x is x plus 1, 3x plus 3 and this term x plus square root of 5 by 3, the next term x minus square root of 5 by 3. These are the four zeros of this given polynomial. Okay, now I think you would have got it. Then going to the next sum, the fourth sum. Okay, even though this sum is a lengthy sum, it's easy, quite easy. I got all zeros, right? So it's quite easy sum. Starting with it, we call it p of x divided by g of x. We get q of x, quotient of x plus the remainder of x. Okay, this is what is the general formula of any division. Okay, here it's a polynomial division, so of x is given. So now what is given is, they are not given g of x, they have given a p of x, they have given quotient of x and they are given r of x. They are asking us to find g of x. Okay, that is the sum. So what is given? I am just writing it out now. 3 x power 3 minus 3x square, x power 3 minus 3x square plus x plus 2. When I divide it with some g of x, we don't know, that's not given, I get the quotient is equal to, q of x is equal to x minus 2. Okay, and I get a remainder minus 2x plus 4. Okay, this is what is given. And now you have to understand that in a normal division, suppose if it's a number, if you want me to explain it, I will explain it with a number so that you can understand it very easily. So that I will explain it with a number. Consider this as simple numbers 7 by 2. Okay, let us not have this number, let it be x itself. 7 by x is equal to, I get 3 plus 1. Suppose I can convert this into simple numbers. So I write 7 by x is equal to 3 plus 1. Now what I do is, I have to find x. I will keep it like that. First this plus 1 I am going to subtract it. 7 minus 1. I get 6. Okay. Then if I divide 6 by this one 3, I get 2. So I have found 2. When I substitute it and see in the place of 7 by 2 I get 3 plus 1. Yeah. So what we have done is correct. So I am going to do the same thing for this polynomial also. First I have to subtract whatever is the remainder. Then I divide that whichever remainder I have got, I am going to divide it with this x minus 2. Then I get g of x. That is the way we have to find the g of x. Okay. So we have to continue it with subtracting first. The first part is subtraction. So x square cube minus 3x square plus x plus 2. This term whole is going to come here as minus. Okay. Minus 2 minus 2x plus 4. When I subtract, minus is going inside. So this term becomes x cube minus 3x square plus x minus plus 2, and here minus into minus plus 2x and minus 4. Okay. So x and here x term and here is an x term. So these both together becomes x cube minus 3x square plus 3x, and this term minus 4 and plus 2 becomes minus 2. Okay. So I have got a new p of x. With this new p of x, I am going to divide it with x minus 2. When I divide it, I get the g of x. So to divide, I will do it here only. X cube minus 3x square plus 3x minus 2 divided with x minus 2. Okay. So it's a normal polynomial division now. X cube, the rough column, and let us do the rough column here. X cube divided by x is equal to x square. So I write the x square here. Then x square into x minus 2. It's equal to x cube minus 2x square. X cube minus 2x square. I subtract, so I change the symbols. This term becomes this term get cancelled. The remaining is minus 1 x square plus 3x. I bring the next term down. Now again x square minus x square divided by x. It is equal to minus x again here. So minus x. Minus x into x minus 2. When I multiply, minus x square, minus into minus plus 2. So x square minus 2x plus 2x. So plus 2x. I change the symbol again and it gets divided, cancelled, and the remaining term is plus 1x, and I bring the next term minus 2 again. Then again x by x is equal to 1. So plus 1, and I divide it as, and this becomes 0. So I have got g of x. The g of x is equal to x square minus x plus 1. Simple answer. The only part you have to remember is first subtract the remainder. Then go divide it with the quotient, you get the g of x. Now into the fifth sum. In the first part of the fifth sum, it's just they are asking us to make the polynomial, give an example and show that p of x by q of x, where q it's equal. The degree of p of x and degree of q of x, we have to make it as equal and show that. That's it. Okay. It's very simple. You have to show that let the p of x, whatever p of x, you are making an equation, right? It's an example sum, so we can make any p of x. 6x square. If I am going to write it as 6x square, then they want a g of x also with x square term. That's all. That's the only point in this sum. Plus 6x plus 3 divided plus 2x plus 1. That's all. The degree should be equal. That is the only point they wanted to show. g of x should not be 0, it's not 0. So the degree of p of x. So degree of p of x by degree of p are 2 by 2 is equal to. That's it. Okay. So the algorithm is satisfied. Okay. The degree is equal. That's what they asked us. So it's not write like this. I will write it like this. The degree of p of x and degree of q of x are equal, and so the algorithm. This is the required. This is an example of the required polynomial p of x and g of x. And the second sum, they wanted to show us degree of q of x and degree of r of x. How are they related? Okay. And they want it to be the same. Degree of q of x, the quotient of x, should be equal to the degree of r of x. Okay. So they want such a degree of let p of x be. All these we are giving as an example. So let p of x is equal to x cube plus x, and g of x, let it be x square. When I divide, I get x cube plus x. When I divide it, I get x square. So x cube by x is x square is equal to x. So x I get, I divide, multiply x into x cube, x square, I get x cube. Then the next term, x, it is smaller than x square term. So I can't divide, this becomes the remainder. And so g of x is equal to x, and the remainder also is, remainder of the polynomial is also x. Both are of the same degree. So this is the required q of x and remainder of x. These are the required. Then next sum, the third sum. Here they asked to give an example of remainder of x is equal to 0. They want to give an example like that. So if I am going to take p of x is equal to x cube plus 1 and g of x is equal to x square. If I am going to divide it, I get x cube plus 1 divided by x square. So I have x here, when I multiply x cube again. So the next term I get 1. So I can't divide, this is smaller than this, I can't divide, so this becomes a remainder. So quotient of x is equal to x power 1, and the remainder of x is equal to, and it's a constant number, so there is no x term, so the degree is 0. There we are talking only about the degrees. So degree of q of x is 1 here, and degree of r of x is 0. So this is the example what they asked us to give. This is the p of x and g of x, where the remainder of x will be, the degree of the remainder of x will be this. That's it. With that we are finishing polynomials.